Hello students, I am going to start a lecture series for you for subject of data structure. Data structure is the backbone of computer science. So let's start with introduction and definition. Data structure is a representation of logical relationship existing between individual elements of data. It means how we can store data in the memory and what are the efficient way of storing data in the memory, how we can decide it. So data structure, using data structure we can ensure that what are the complexity of the particular algorithm. So data structure is very essential subject for the students. In the other words, a data structure is the way of organizing all data items that consider not only the elements stored but also their relationship between each other. It means how to store the data and how to relate it with one data with the other data, what are the relationship between, or how it these are dependent on this variable or these variables or the combinations of variable. We can ensure that using the data structure and how to reduce the complexity of related to data, like complexity, time complexity and space complexity are the very crucial this time. Data structure affect the design of both structure and functional aspect of the program. We are if you want to generate a simple program, we give any algorithm and also be essential data structure. What are the data structure we involve in this algorithm is the very important question. You know that the algorithm is the step by step procedure to solve the particular function. That means algorithm is the set of instructions written by carry out certain tasks. The data structure is the way of organizing the data with the logical relationship. So if you want to develop any algorithm, data structure, how to decide a data structure is very crucial task, because many data structures are available like array, linked list, stack, cube, tree and graph. What are the complexity of these data? Without the studies of this, it is the impossible for generating a efficient algorithm, and the without a efficient algorithm any programming is not possible. So data structure is very efficient, very essential subject for computer science and engineering student. Therefore algorithms and its associated data structure from a program. Classification of data structure, mainly basically two types of data structure: data structure, primitive data structure and non-primitive data structure. What are the meaning of primitive and non-primitive data structure? Primitive data structure are the predefined data structure like integer, float, character, pointer. These are the type of data. But non-primitive data structure is normally performed by user or programmer. Classification of data structure: non-primitive, or we can say defined by programmer or developer. In this series, first is linear list. Two examples are here, array and queue. These are the linear list, and Linked list stack also include in linear list, and in non-linear list only the two are we are going to cover graph and trees. Primitive data structures, these are basic structure that directly operated upon the machine instructions. In general, there are different representation on different computers. Integer, floating point number, character, constants, string constants, pointers, etc. fall in this category. Non-primitive data structures, there are more sophisticated data structures. These are derived from the primitive data structure. The non-primitive data structure emphasize on structures of a group of homogeneous same type or heterogeneous or the different type of data item. Non-primitive data structures are linked list, stack, queue, tree. Graphs are the examples of non-primitive data structures. The design of an efficient data structure must take operation to the perform on the data structure. Non-primitive data structures are many operations performed on it. The most commonly used operations on data structure are broadly categorized into following types: create, selection, updation, searching, sorting, merging, destroy or delete. Difference between them: a primitive data structure is generally a basic structure that is usually built into the language, such as an integer, a float. A non-primitive data structure is built out of primitive data structure linked together in the meaningful way, such as or a linked list, binary search tree, AVL tree, graph, etc. Description of various data structure in series. In this series, we are going to discuss array. An array is defined as the set of finite number of homogeneous elements or same data items. It means an array can contain one type of data only, either all integers, all float point number, or all are characters. Array. Simple description of array is as follows. In array, where int specify the data type or type of element array stores. Array is the name of array. The number specified inside the square brackets is the number of elements an array can store. This is also called size of length of array. Array. Following are some of the concepts to be remembered about array. The individual array elements of array can be accessed by specifying name of the array following by index or subscripts inside square brackets. The first element of array has index 0. It means the first element, the last element will be specified as 0 to 9 respectively. Arrays, the element of array will always be stored in the continuous memory location. The number of elements that can be stored in the array, that is the size of array, or its length is given by the following equation: upper bound minus lower bound plus 1. Array. For the above array, it would be 9 to 0 plus 1 is equal to 10, where 0 is the lower bound, the array, and 9 is the upper bound of the array. Array can always be read or written through loop. If we read a one dimensional array, it requires one loop for reading and another for writing the array. For example, reading an array 1 is equal to 0. Here we can initialize I is equal to 0, I is less than is equal to 9, I plus plus. Scanf for reading the array, we can give address using ampersand sign and the name of array with the variable I. For example, writing an array for 1 to 0, 1 to 9, I plus plus, print D array for printing any array. Thank you. Students, here I am taking some examples from internet. You can use it and practice it directly from the internet, or you can use from my channel. These are the very good examples, and using graphics so you can understand deeply how to perform these operations on stack, queue, and what are the structure of queue, and how to implement trees using the data structure, different types of trees like heap, hash table, matrix, etc. Very good examples are here, so you can use directly from the internet, or you can use from my channel. What are the need of data structure? Please practice it, and what are the applications and how to classify these data structure. Please practice it, because it is very important subject for any student of CSC department. Please take these examples, classification of data structure, and what are the different types of classification, linear data structure, non-linear data structure, what are the use and applications of these data structures. Please practice it to take the depth knowledge of this subject, because this subject is the backbone of CSC department. Without data structure, not possible to study any of CSC department subject like automata theory, machine learning, AI, deep learning, data science, all are essential, but the backbone of this subject is the data structure only. We can use many languages with the data structure, but the C is the also a backbone or only single middle level language available. So we are normally use C with data structure. Data structure using C is the very essential subject for any student of CSC department. Kindly take these examples and applications of data structure, and where we can develop using data structure operating system, graphics, computer design,